Good morning. Now, hence, after I am going to upload some lectures. And in that lectures, uh, I am going to solve some exam problems. That is, problems from previous university question papers. We will be a little bit fast over there, and to understand this, you have to refer these videos, and so that you will understand it very clearly. So these videos are in playlist of mechanics of structure, that is strength of materials. We have this as draw shear force and bending moment diagram of a simply supported beam as shown in figure. So we have this as VA, this as VB. So now we will take moment about B0. We have VA into 6 minus 20 into 3 into. This will act at center. So that is 20 into 3. This will be force. And it will be 1.5 meter from C. So 1.5, 1.5, 1.5. So it will be 4.5 minus this 40 into 3 plus 120. And that is equal to 0. And by this, we are going to get value of VA, that is equal to 45 kilonewtons. Now we will apply summation Fy is equal to 0. And by this we will get VA now becomes 45. So we have 45 minus 20 into 3 minus 40 plus VB equal to 0. And we will get VB is equal to 55 kilometers. Now we know VA 45, VB we have 55 kilonewtons. Now we have to plot SFD. Now we know for SFD we have to find out. So we have shear force diagram. So shear force we have to calculate left and right of concentrated load. So left of A 0, then right of A 45 kilonewtons, then left of C. Actually we are starting at end of UDL, but as at end of UDL we have concentrated load. So left of C we have 45 minus 20 into 3. So it will be minus 15 kilonewton. Then we have right of C. So we will plot simultaneously actually. So we have 45, then minus 15. Then we have right of C, minus 15, minus 40. So it will be minus 55 kilonewtons. So minus 55, then no load between C to D. So directly left of B. It will be as it is, no load. And then right of B, it is 0. Right of B equal to 0. So we have likewise. So now you can see this. When we have x to the power 0 in UDL, we will get x to the power 1 in SFD. Here we do not have any load, so it will start from 0. Then we will go to bending moment. So we have bending moment diagram. We will have to start again from left. And then we have at support 0, at concentrated load, starting and end of UDL, and left and right of couple. Then we have at A we have 0. Then we have at C, we have 45 into 3 minus 20 into 3 into 1.5. So we have this value 45 into 3 minus 20 into 3 into 1.5, 45 kilonewton meter. Then we have left of D, you can come from right side also. So we have 45 into 4.5 minus 20 into 3 into 3 minus 40 into 1.5. So we have 45 into 4.5 minus 20 into 9 minus 40 into 1.5. It is minus 37.5 kilonewton meter. Then we have right of D. So we have to just add these other things remain same. Minus 37.5 plus 120. And it will be 82.5 kilonewton meter. And then at B, we have 0. Now we have to find at 0 shear force. So let us, we have X, at X we have 0, and therefore we will get 40 shear force equal to 0. And we have 45 minus 20x equal to 0. And X we will get it as 2.25 meters. So we have 2.25 meters. And therefore we will get M max equal to 45 into 2.25 minus 20 into 2.25 square by 2, and we will get this value that is equal to 50.63 kilonewton meter. So now we will plot it A0. Then at 2.25 meter, we have 50.63. So you can see we have this as 2.25 meter. Then at C, we have 45 kilonewton meter. Then at left of D, we have 37.5 kilonewton meter. And then right of D, 82.5. And at B, 0. So now I will explain this. Now you can see this. We have, this is x to the power 0. This will be x to the power 1. Here we do not have anything. So start from 0. Always start from 0. And then we have bending moment. You can see here x to the power 1. Here x to the power 2. If bending moment increases, slope decreases. Slope decreases. Bending moment decreases, slope increases. Decreases, but slope increases. So we have to keep in mind this part. Now, this is x to the power 0. So we will have this as x to the power 1 increased by 1 from loading to BMD. Then we have another problem in this B part, and SFD is given, and we are interested to draw loading diagram and bending moment diagram. So now we will go with this. We have to use two formulas over here. If we will have concentrated load or reaction, so concentrated load or reaction means vertical line or reaction, and this we can get it. We have vertical line in SFD, vertical line, and then we will have this equal to final shear force minus initial shear force. And if we have linear line, then we have UDL, that is equal to final shear force minus initial shear force upon span. and then we can find the values. Now we will go with this. So we can have this. So we have at A. So we will simultaneously we will draw it. So at A we have concentrated load, or I will say reaction, because value is positive. So reaction. So we have final shear force 19.5 minus initial 0. So I will get 19.5 plus. That means we have this as reaction upward. Generally plus, then it will be reaction. Now we have linear line between A to C. So we have UDL between A to C. And then we have final shear force is minus 16.5, this value. And initial we have 19.5, so minus 19.5, span is 6, and we will get this value minus 6 kilonewton per meter. Minus sign shows it is in downward, plus will show upward, so 6 kilonewton per meter. Now at C, as it is vertical line, so we have again a reaction, because we are going to get value positive, because final shear force is plus minus of minus initial 16.5, and then it will be 25.5 kilonewton. So we have this value reaction 25.5 kilonewton, and then UDL between C to D we have equal to final shear force 0, and then we have initial minus 9 and span is 2, so it will be minus 4.5 kilonewton per meter. That means it is in downward direction. So now we can see this, it is in downward direction. Now we have to check summation Fy0 and moment about any point 0. So I will take moment about A0, and then we have 6 into 6 into 3 plus we have 4.5 into 2 into 7, and then minus 25.5 into 6. So we have 6 into 6 into 3 plus 4.5 into 2 into 7 and minus 25.5 into 6. So it comes plus 18, means we have to apply minus 18 to this, and then only it becomes 0 and in equilibrium. Let us, I will assume 18 kilonewton meter. That is your choice where you have to assume. I will assume here, so we need not require to consider anywhere in the calculation for BMD. So we have this as 18 kilonewton meter. And now if you will check it, then you have minus 18, and then it becomes 0. And Fy we have 0, you can check it. 6 6 are 36 and 9 45, and this is also 45. So that is correct. Now we will go for bending moment diagram. Now you can see, if you will see, I will draw loading diagram over here, and then we will go bending moment diagram. So now we have reaction over here 25.5, reaction over here 19.5, and then we have UDL over here 6 kilonewton per meter, and here 4.5 kilonewton per meter. So now write these values. So we have 4.5 kilonewton per meter, and this is 2 meter, and then we have this as 6 meters, and UDL we have 6 kilonewton per meter. Now we have to find out maximum value. UD bending moment we have to find out. So we have this as 18 kilonewton per meter. So 18 kilonewton meter moment. Now at A we have value equal to 0. Then we have at C, so it is 19.5 into 6 minus 6 into 6 into 3. And then we will get it as 19.5 into 6 minus 6 into 18, and we will get plus 9 kilonewton meter. Then we will find this is at C. Then as we have couple at D, so we have left of couple (19.5 into 8 minus 6 into 6 into 5 minus 4.5 into 2 into 1. And then we will get this value minus 36 into 5 minus 9. So we have 19.5 into 8 minus we have 6 into 6 into 5, then minus 4.5 into 2, and then we have due to 25.5 into 2 plus 25.5 into 2, it is plus 18 kilonewton meter. So left of couple means left of D and right of D is 0. And then we have to find out at 0 shear force, we have to find out this point, that is 19.5 by 6. This comes 3.25. Already I explained in last, we have shear force equal to 0 equal to 19.5 minus 6x. And we will get x 3.25 meter. And therefore M max we will get 19.5 into 3.25 square minus 6 into, 19.5 into 3.5 and 6 into 3.5 square by 2. And we will get this value that is equal to 3.25 minus 6 into 3.25 square by 2. And we have 31.69. Now we will see it. So we have BMD 31.68, which is at B. Then at C we have plus 9. So 9 kilonewton meter. And then we have 18 over here. And then 0 at D. So likewise we have to go. Now this 18 you can consider anywhere. I have considered end, so we do not have anything in calculation inside. Now you can see this. So SFD we have x to the power 0. X to the power 1. So UD here we should have x to the power 0. Here again we have x to the power 1. So it will be x to the power 0. And BMD we have throughout x to the power 2. So likewise we have to solve the problems of SFD BMD. This is from mid 2017, question 5. Next video we will see question 6. So now we will stop here only. Thank you.